Hi. So using our knowledge of indefinite integrals, today in this video I'll make a table of integrals. Okay, so some function and their integrals. Now let us quickly revise what does an integral mean. So if you have some function plus a constant and you differentiate it to get f of x, then this f of x is said to be the antiderivative or primitive of f of x, and this integral, this indefinite integral f of x dx gives you all the family of such antiderivatives. So if you differentiate f of x to get f, small f, then you integrate small f to get capital F. Okay, and this C is for generality. So for example, if x square by 2 is your capital antiderivative of x, then x square by 2 plus some constant 1 2 3 4 5 anything will also give you x. We discussed this example before. Okay, and this works because derivative of a constant is 0. So now let us use our knowledge of certain functions to make a table. So first step, let us consider sin x. Okay, so d by dx of sin of x, okay, sin x plus some constant. So it is the same as differentiation of sin x, because differentiation of a constant is 0. This is cos x. Okay, this means that if you integrate cos x dx, you will get sin x plus some constant. Okay, if you can easily compare. So capital F is sin of x and the small f is cos of x. Okay, so sin x plus c is the family of antiderivatives of cos x. Okay, because the cos x is the derivative of sin x. So if f of x is your cos x, okay, not capital F, small f. So small f is cos x, you can see. Then your capital integration f dx is sin x plus some constant. Okay, now what is the derivative of cos x? D by dx cos x. Okay, cos here represents the capital F. Okay, not the small one as the previous case shows. Cos x plus some constant. Okay, it's the same thing as the derivative of cos x. Okay, which is, if you remember, it is minus sin x. Alright, so the derivative of cos x plus c is minus sin x. Now you integrate this thing to get cos x plus c. So integral minus sin x dx. Okay, indefinite integral minus sin x dx is cos x plus c. So the minus, okay, pops out and goes to the LHS. So we get minus goes out away, minus cos x minus c. But the thing is, c is a constant. Okay, c just represents a constant, any constant value, and you multiply a constant with -1, it will still remain a constant. That's the key. So you can just simply absorb -1 into your c. You can also write it as minus cos x plus c. So f of x is sin x minus cos x plus c. Now using this same method, using this exactly same method, and if you remember the derivative, the table for derivatives, then you can easily construct the table for the antiderivatives. I'll show you all the antiderivatives of trigonometric functions. So these are all the antiderivatives. Tan x plus c, sorry, sec x plus c, you integrate sec square x, you get tan x plus c. Okay, you can see why d by dx of tan x plus c gives you sec sec square x. So you integrate sec square x, okay? Integration, indefinite integrations, sec square x dx will give you this part, tan x plus c. So I've just written down the expressions, okay? Cos x square x gives you cot x plus c. Sec x into tan x give you sec x plus c, okay? Cosec times cot x into cot x is minus cosec x plus c. Now let us do some algebraic ones. D by we studied this one, so differentiation now, 1 upon n plus 1 to the power x into x to the power n plus 1, okay? We did it in our previous video. This gives you x to the n. So from this you can say that, okay, integration x to the n dx is x to the power n plus 1 upon n plus 1 plus some constant, okay? And the important thing is n cannot be equal to 1, otherwise the denominator will be 0. Let me just write this down. X to the n, and f of x is x to the n. Your integration is x to the power n plus 1 upon n plus 1 plus the constant. What will happen if n is equal to minus 1? Okay, let me just write it down. N equal to minus 1, not equal to minus 1. Okay. So we know the derivative d by dx of your natural log, okay, ln x. This is your 1 by x. Alright. So your integration 1 by x dx, okay, is ln x plus c. So 1 by x is ln x plus c, and 1 by x is x to the power of minus 1, so n is equal to minus 1 in this case. This is your general, and for n equal to minus 1 you get ln x plus c. Now e to the power x, okay, e to the power x is a special function. D by dx e to the power x plus c is the same thing as e to the power of x. Alright, so integration e to the x dx is also e to the x plus c. So e to the power of x kind of remains same. Alright, and consider this one, e by dx of e to the power of x. So x is in the exponent here, okay? In our previous case some other number was in our exponent, but in this case your x forms the exponent divided by ln a, okay, plus some constant. So it will be 1 upon ln a, so it's a constant. We pull this out of our differentiation, and differentiation of a to the x, okay, d by dx c is equal to 0, and this is 1 by ln a times this part is ln a times a to the x, okay? So the ln a cancels out, and of course a has to be greater than 0 and a should not be equal to 1, because ln a is log base of e and it follows all the properties of logs. So from this you get integration, indefinite integral a to the power of x dx is to the power of x divided by ln a plus c. Let me just write this down. A to the power of x, a to the power of x divided by ln a plus c. So in this video we revisited the concept of indefinite integrals and formed a table for certain functions. In the next video I'll tell you how to use these functions to integrate some other functions. See you next time. Thanks for